Hello everyone, I am Shruti Pawar. I have done my second task given by the Spark Foundation, and task is prediction using unsupervised machine learning, and statement is from the given iris dataset predict the optimum number of cluster and represent it visually. So in this, first of all, I have imported all the required libraries. Then I load the iris dataset. Here I have displayed the first 5 rows from the dataset using head function. Then using shape, here I have displayed the number of rows and number of columns. So 150 is my number of rows and 6 are my number of columns. Then here I have used info method for ensuring is there any null value present or not. So it gives me the output 150 non-null. So it indicates that there are no null value present. After that, I have described the dataset. It gives me some statistical information about the column, that is mean, minimum value, maximum value, etc. After that, I have dropped the column which is named as ID using drop function. After dropping column, I am displaying the values from the data frame. After that, here I have plotted the box plot for every column, that is sepal length centimeter, sepal width centimeter, petal length centimeter and petal width centimeter. So in the second graph, that is sepal width centimeter, we can see there are some outlier values that are present. So I have removed those outlier value using IQR technique. So in this technique, we have to calculate lower bound and upper bound. For this, I have taken 25 and 75% of that column using quantile method. After that, I calculated IQR by subtracting those values. Then using formula, I have calculated lower bound and upper bound. So 2.05 is my lower bound and 4.05 is my upper bound. So the data which is less than 2.05 and the greater than 4.05 are my outliers. So here I have removed those outlier. After removing outlier, I reshape my I displayed the shape of the data frame, that is 146 and 5. The next is a finding optimum number of cluster for k-means classifier using LBO method. LBO method is nothing but it is used to determine the number of cluster. For this, we have to calculate WCSS, that is within cluster sum of squares. For that, first of all, I have taken the values from first 4 column using ilog method. After that, I have imported k-means for sklearn cluster library. So this for loop fits the k-means algorithm to our data and also compute the WCSS and append it to our WCSS list. So in this k-means method, I have passed n cluster as I. N cluster means how many number of clusters you want to create. Maximum iteration 300. Then I fit my data to the model. Here I append the k-means inertia to WCSS list. K-means inertia is nothing but the sum of square distance of sample to their closest cluster center. After calculating it, I plotted the result. This graph is similar like arm. So from this we have to take a pinpoint in such a way the point onwards data should be in linear manner. So I have taken 3 point. We can see after point 3 our data is in linear manner. So I take my k as 3. K is number of cluster. After that, I apply the k-means to the dataset where number of clusters are 3, and then I use fit predict method. It returns for each observation which clusters it belongs to. After that, I have displayed the values for k-means. After that, I have done visualization of the cluster. So there are 3 categories, and for the 3 categories I have used different colors. For the plotting centers of the cluster, I have used cluster center attribute. It returns a coordinate for the centers. So in this scattered graph, we can see there are 3 clusters colored blue, red and green, and here we can see yellow star. which indicates the centroids for that cluster. So in this way, I have completed my second task. Thank you.